Hi, I'm Nick. I'm a lead instructor at Nebula Academy, and today we're going to be talking about microbits and how they can be used in education.
All right, these are my favorite product of all tech. And the reason why I love them, cheap, durable, right? And any age, literally any age.
Yeah. I like them so much because you can scale up everything that you're doing to be really basic or be really complex. Similar to a lot of other, micro computers or processors out there, you can attach more complex stuff onto it. So, you make your initial investment, you work with them for years with the students, and then let's say they're reaching senior year and they want to get into something more complex, you can go ahead and add on to these.
Yeah, no, so it's a great product. Again, cost about $30 or less. It depends on what you buy for this. So you can get them as low as down to like $15, $20. They're like stock sometimes, I think, because it's hardware and it's tech stuff. The prices kind of go up and down based on, availability.
COVID.
Yeah, COVID. Yeah, we've had some situations. So if you do plan on using these, just be proactive. Don't think you're going to get them in within a week. All right. So you got to go search them. A lot of great places to get these from. You can buy them from us, from Nebula Academy, but you can certainly get them from Amazon and Adafruit, and sometimes we will buy our stock from them as well. They're a local New York company. I love them for that reason, and they're right in the Bronx, I think, Adafruit. So just a plug for Adafruit. They're a great company to work with, and yeah. So again, drag and drop. Right? We're going to talk about drag and drop and scaffolding. This is just a little different. What's really kind of cool about this from a K through 12, and there's a story behind the microbits. Microbits were actually started by the BBC in the UK. So they really are trying, in the UK, they're really concerned about kids' education and about their ability to think computationally and to really apply hardware and software together. So they basically did an initiative to give every student, I forget what age group and up that they were doing this with, in the country, one of these devices to learn on. And so, and that they actually designed these in collaboration with some other industry partners. And so they're not for profit, and all the funds that they generate from the licensing of these, they use towards education programs, which I think is a great model. And so another reason why we like them, it's a good partnership for us to be able to sell them and to be able to use them in our education programs. What else? So again, kindergarten, literally can use these with kindergartens. I think the big things with these, I'm going to go ahead and pick one of these up. You see this gold here, your oils on your skins, we teach this to the kids, not to touch that area, just kind of hold the sides, that way you don't get the oils on your skins on the components, otherwise it could make the components fail. And then what's nice about this is an IoT device, right? So if those of you who are listening and don't know what an IoT device is, it's Internet of Things. And so if you're trying to teach IoT to kids, this is a great way. Cell phones are phenomenal. They're considered an IoT device, and there's lots of IoT devices out there. There's sensors, farmlands use them all the time. And so when we think about this and teaching kids about IoT, what's some of the stuff that you can do on here?
So it's got radio. They're really just like the cheap versions of what you might get in your phone, right? Yeah. So instead of having Bluetooth, it's got radio. Instead of having a screen, it's got LEDs, right? So from a development perspective, that's all awesome because you can see it, the students can interact with it, and they're learning. From an IoT perspective, some of the stuff you can do is moisture monitoring, maybe for watering with plants. There's a lot of ways to go with it. What we're going to be showing today is all of the microbits that we have syncing up and flashing at the same time.
What are we simulating though?
Yeah, so we're simulating.
This is the education bring-in piece.
Unique fireflies. I believe they're in South Africa that actually, unlike the ones in the US that we see, which blink randomly, they start blinking like groups, and then they will eventually just sync up and all blink at the same time. So
which is kind of cool for kids to see, right?
Exactly.
So if you're a biology teacher or you're teaching some module on nature, you could bring this in and get kids really excited about it, and also teach the concepts of nature too.
And there's a massive amount of content and programs that exist through Microsoft MakeCode.
Yep, and it's free. No cost to use Microsoft MakeCode.
So, for example, the fireflies, there's an actual video of the fireflies doing it. there's the history behind it, the biology behind it, right?
All the curriculum you need.
They're trying to do the full STEAM package. It's not just this is coding or this is science, right? You can paint a whole picture and really lean into the project-based learning.
Yeah. Yeah, I like that. And you can literally have the kids do a coloring project along with it, or they could do some kind of report where they have to present on what they're doing. And you can bring in the SDGs for this too, the UN SDGs for this as well, because they could think about what problem they want to solve with these. Yeah. And I love to let kids be aware of the evolution or the changing dynamics of the workforce, right? And how these types of technologies are playing a role in that.
Yeah, yeah.
Very cool. All right, so what are we doing next?
All right, so what we're going to do is actually show the microbits in action. We're going to start off with our basic hello world, right? So most of the time when you're using any sort of technology, you want to get started with something really basic. Make sure that you can give a command and you can get a response, right? Microbits don't have a command line, which you might use with some of the more modern languages. We're using drag and drop coding instead. So we're just going to create an action and look for a response. We've actually got that set up on this microbit right here. So here what we've done is we've plugged in the batteries just right into the port in the back. And we can see now that our microbit is running the program that it's got on it, which says display a heart.
Yeah, so we've got a USB cable here that we use and they are short, so that's one of the things too that I do see educators doing is that they might buy like longer ones because sometimes with especially younger kids, when you're plugging in that short USB cable into the laptop, now there's pros and cons to that. Having short is sometimes a good thing because they can't get caught in things, but sometimes it can be a negative aspect depending on your classroom and your preference. So you as an educator or whoever, or parent or summer school program, however you're using these for, again, these are so versatile in how you can apply them in learning. So we want to encourage those folks that are doing summer programs. These are a great, inexpensive thing to introduce kids to. And again, parents who are out there teaching their kids can do this. And of course, educators. This is a great product to invest in. And again, just like other products that we've shown you, is that this is a low cost investing in it, and it'll scale for you. So they need to have the USB cable, or they come with the USB cable and this power cord. But sometimes when you buy them, you just be careful of that. Some of the kits will come just the microbit, and that's it. So you just make sure that when you're shopping for them, you want to make sure you get a kit that has the power device and the USB cable as well as the microbit. And because otherwise, if you see them really cheap, that's usually why. It's because you're only getting the microbit and not getting the other stuff with them.
And honestly, as you can see, it's pretty simple, just the 3 parts, right? But what we do in a lot of our programs is we actually build stuff, right? Yeah. Stopwatches, name tags, clocks. Oh, the fun one is there's a separate stopwatch piece. There's a timer and there's a clock. They're all separate programs. And then if a student is doing really well and he's ahead of the day of the program, I'll say, okay, get all 3 of those programs onto one device. Right?
Now, I love that you said that, because here's the deal. When you have a classroom, right, and you've got some kids are just learning this, and some kids are really like, I'm bored, I've done this before, right? You get those students in the room. When you introduce this, you can give them that independence to kind of say, hey, you know what, go ahead, keep going, keep learning, and here's some more stuff that you can do, here's more projects you can do. So you can prevent the boredom from happening. Or what I've done as a technique with educators is showing them how to model the student helping other students. Because typically when you have a student who's bored in the classroom, as educators you know, then you have behavior issues typically, right? So if you want to get that one student who's really bored engaged, let them help the other students. Let them go in there and teach and show the other students how this stuff works. And they love that because they want to be that. They want to kind of shine and show their capabilities with their peers. And so it's a great way to kind of leverage students to help you with this. Because sometimes, and this is the other thing too with educators, that uncomfortableness that might be, oh, my kids know more than I do. I don't want to do this because I don't know this stuff. I love this because it's a great first kind of venture into this for an educator who's kind of like want to take a little risk and they want to bring a little something interesting into their classroom, and they're okay with not knowing everything and not knowing more than their kids, and then let the students be part of the learning experience and embrace that learning together model. And this is a great tech to do that with.
Yeah, a big focus on tech is knowing how to figure out what you don't know, right? And that can be especially tough for a teacher because that's not what they studied, right?
Yeah.
As a someone from tech, I'm very comfortable with this because That's what I do day to day. As a teacher, there will be some scaling you got to get, or some training to get used to saying like, oh, I like that. Let me just go figure it out, right? And nowadays, a lot of the stuff is getting curriculum built around it, which is super helpful. So you can always drop in microbit, half your curriculum. You could do the same thing with drones, Raspberry Pis, whatever it may be.
Yeah, very good.
So what we're going to do now, all of these have the program already downloaded to it. So what we're going to do first is show what that looks like to get it onto our device that is not trying to do the fireflies yet, right? So what we've got here is our drag and drop environment, right? What we're looking at is the firefly code, right? So there's a little more complexity going on here than you might expect, I guess, just looking at this one flashing piece. And even if we plug in one of the fireflies, I'll put it right next to my heart. All we're seeing is just a flashing light, right? But this is flashing and then checking its radio signal to see if there are any other devices.
Any other fireflies around? Exactly,
any other fireflies looking to match up and sync with it. So I won't talk through the code right now, but I'm gonna show everybody how simple it is to get code onto an existing device. So I'm taking my Hello World or my Heart device, and I'm just plugging in the USB, and we'll just pause for a second. All I need to do is go ahead and click download on this. Go ahead and click on my downloads down here. So I'm going to my Finder. It's already in my downloads folder. And you can see right here, we've got the third version because I've clicked on it a couple times. So I'm going to finish plugging in my microbit. And now we should see that pop up on the side right here. And I'm going to go ahead and drag any of these firefly pieces, and I'm reflected. There you go.
So Nick, this brings up a great question, which I know people are going to be asking. What kind of devices can you use this with?
Yeah, so I've never done it with Chromebooks, but I know on Windows and Mac it absolutely works. There's no reason for it not to work on Chromebooks in my mind.
Yeah, as long as the Chromebook has a USB port.
Exactly, USB port and a tiny bit of memory. Sometimes they're filled to the brim, right?
Yeah. But students would need to, from a secure, I know administrators at schools sometimes lock down the Chromebooks and stuff. So there's nothing really downloading to the device. You're really just downloading to the USB drive on that. It becomes a USB drive.
And the coding environment is web-based,
it's all
browser-based.
Yep.
So we like to use Chrome, but you could use Safari or Edge, whichever you like.
Whatever you prefer. Yep.
And it often will be blocked by the default settings because you can make games on the coding environment, and anything with the word game in it gets blocked by most schools.
Yep.
So everything's synced up pretty quickly there.
It happens pretty fast.
It happens pretty fast.
But
exactly.
I think you can adjust the code to probably make it so you can simulate it better. Right?
Yes. So what you will often see is in a classroom of 20 plus students, 10 microbits will group up and the other 10 will group up, and then they'll sort of one side will start losing
the synchronization with the other?
Losing somebody every now and then they'll all get into sync. Yeah. And obviously, I don't know, we're so used to it now that seeing everything in sync is not so exciting. But this is pretty cool for the students because they're actually interacting with their classmates' microbits. So, right, like Nick's microbit is communicating with Lori's microbit. And there are lots of different activities that achieve the same piece, but there are games that you can play, like someone is infected, right? And I guess this is more relevant than ever. And the goal is for that individual to spread the infection by getting near the other students.
Right. And so then the other thing too is it has A/B switches on them. So I like that too. If you really want to get advanced with your students and kind of take it to another level, kids love to play Pong, and Pong is a great example of a game that you can play on the microbits and actually create this game for the students. So gamification and learning is just an amazing way to get kids excited, and there's just so much potential with these devices.
Yeah. If I'm going to talk about games, so Pong's a good one. stop the dot, so the dot will just like bounce left to right, and you're trying to stop it in the middle, and you get a point every time you get it. Out of the box, super easy. The dot in the middle is going to move at the same pace, and you get a point every time you match it in the middle, right? Conceptually pretty easy. Coding's a little bit more difficult. But if you want to take it to the next level, you say, okay, how do we get the dot to accelerate based on score, right? So now you're integrating a little bit of math into your coding, and of course the students are motivated because they
well, it's applied math too. This is what I love about it. Just like the drones, right? It's applied math. So, you know, educators, you know, sometimes it's hard to get that light bulb to click and go off of the student because they're like, they just don't get the real application to it. And they need to see that. They need to see it and feel it and like emotionally be tied to it, right? And that's really what creates the stickiness and the learning. And so these kind of really are a great stickiness tool.
Yeah.
All right. So anything else you want to share?
No. As a teacher, they're pretty good because it makes instructing more fun.
Yeah, it does.
It's more fun doing this than reading off a whiteboard. I'll say that.
Yeah.
So that would be my big highlight from a selfish standpoint as to why you, the instructor, would like to work with the microbits as well. Yeah.
And I think group team building, project-based learning, this stuff is phenomenal for it. Maker, they can make guitars, they can make like watches and wear and they can get into the makey part of it too, right? So that way they can, you'll see these projects out there on the Make Code website. It's all this is available to you. There's full curriculum out there. So again, that's a lot of reasons why we like this product and utilize it often. So thank you again for joining us. We'll look forward to seeing you again next week and sharing more tech experiences with you and how we use them in education. So thanks again, and please visit our website to learn more about us, nebulaacademy.com. And if you're seeing value in this program and you want to help support us to provide innovative learning experiences for those underrepresented populations, make a donation to We Connect the Dots. You can visit We Connect the Dots at weconnectthedots.org. Thank you again. Have a great day.